thank you so much for hosting me today. And I'm hopeful that we'll be able to, clarify some things or maybe get ourselves very enthusiastic about cybersecurity data science. I think that this is one emerging field that data science is actually penetrating, which I think that most of us as data scientists on this field, because I know most of you are AI oriented people, and I think you are going to be very passionate about it. So we can just quickly go. So basically, we know that data is one of the most important thing when it comes to AI. And each one of us here is bent on actually wrangling data, doing so many things with data, getting insights from data, and then helping to make some progress in our workplaces or in our businesses with the data. So we say that we already know that data has been growing so fast these days. Research is showing that it is actually doing this at exponential rates, and almost 90% of the data that we produce was actually done in the past 2 years. Yes, and the reason is that now digitalization and then devices that we have around us here now are really helping us to produce all this data, and it's of greater use for us to harness or to harvest this data and then make good use of it. But as we go along this trend of digitalization, connecting to so many services, connecting to so many devices, we should also know that there are also other people who really wouldn't like processes or critical infrastructures to run as it is. Yeah, because data scientists are actually creating values, for businesses. And as we are creating the values, we should also have to see to it that these values are also protected for the businesses. So digitalization is helping and is generating a lot of data. So big data will say that we are actually accumulating a lot of data at a very high speed, but these data sets are not in a form that is easy for any ordinary person to make use of. All right, so let us go on to the next slide whilst we look at some pertinent issues. Okay, so like I said earlier, we have been surrounded by a lot of devices, which popularly called the IoTs, and these devices are producing data. And as they are producing data, we also have other people who are also interested in actually stealing this data. And some of their acts, the very things they do in order to destroy some of the systems that we have destroyed, which we call the security incident. So we say security incident actually is an act that really threatens the security of our information systems. All right. So in other words, they compromise with the confidentiality, the availability, the integrity of the data sets that we are actually, we are actually preserving or we're actually using for our businesses. So from the slide that we have here, you can see that there's a display of all this security incidents that we can ever see. We have the theft of intellectual properties. We also have unauthorized access to computer systems and laptops. We have security incidences where we have accounts being hacked. We have money scams. We have malware induction to our systems. We have denial of service. These are all security incidents that actually compromises with the information systems that we use. So cybersecurity is being stationed to help us protect these systems that we have, to prevent us from all these incidents that we have mentioned or we can see on the slide. So let's please go on. So all these cybersecurity incidents that really happen, the fact is that they don't really happen just for fun, but they actually have great effect on us. And one of them is that monetary wise, we lose a lot of money every now and then through some of these security issues or attacks that we have. So from the slide, you can see that these security incidents, for example, the malware infections, is really rising even as digitalization is also rising. So in 2009, we can observe that there has been a major increase, almost like 800 million of infections really occurred from 2009 to 2018, which is quite very alarming. So we can imagine the individuals, the companies that have been affected. Definitely, monetary-wise, they will also be affected. So we go on to phishing, which is also one of the contributing incidents to our infrastructure. And then we say that almost 17,700 dollars are being lost every minute, and that's a huge amount of money. And these are all caused by the usage or the digitalizations that we have, where it becomes like an open door for hackers, attackers to delve into our information system to either steal our money or to steal our information, which they can use at the end to even blackmail us and take a lot of money from us. So we are saying that cybersecurity really has come to save us from a lot of challenges that we are facing. But then we will say that is it holistic? Is it okay? Is cybersecurity okay in the state in which it is now, where data is being produced day in, day out? Our security professionals really have to task to be able to, make meaningful insight into the data that's being produced. Please, can we go on to the next slide, please? So for those of us who are still new to cybersecurity, though we have some knowledge about it, we are saying that cybersecurity is not just a set of technologies. As we all know, we can make mention of the antivirus, we can make mention of, IDS. That's all that we think. But cybersecurity goes beyond that. There are also practices and guidelines and processes that we have to engage in order to protect all the information systems that we have. And there are several of such divides of cybersecurity, which are the network security, information security, and operation security, which people will have to work hard, produce defenses to prevent attacks from other entities or individuals. And we are saying that for every organization, it is always very important to understand what kind of threats befalls your organization. We would like to understand that, okay, for any organization, who do we think can attack our infrastructure? And then what are some of the weaknesses of our infrastructure and the impact that some of this malware, as we read before, that a lot of infestations are going on. Now, how would we be able to ascertain the impact, know our vulnerable, loopholes, and be able to, overcome them? And this can only be done by any organization that is cybersecurity conscious. So we have to come up with a lot of defense strategies that will help us to be able to safeguard our system. So like we have on the slide, we have antiviruses, which some organization uses, firewalls, IDS. We have some user authentication processes to ensure that we don't have unauthorized people really getting into our system and then stealing our data or stealing our money. Now, again, some other organizations implement defense against attacks by actually ensuring that their data is encrypted so that attackers will not be able to decode them. Some also engage in cryptographic systems, which actually helps them to prevent attackers for deciphering their data and then using them for purposes which are not really beneficial to the organization. So from here, I want us to just have a good look at the IDS, which is one of the main components of cybersecurity infrastructure, which I think is being implemented over the years. And one of the things that it does, or the main purpose of it, is to actually monitor the computer networks or system for malicious activities, and then ensure that there's no violation of policies that the organization has enacted. There are several of the intrusion detection systems, all right? We have the network, those that are network based and those that are host based. But I just want us to look at the makeup of the IDS and how it is protecting our information systems, and as to whether the protection it is giving, it is okay, that there is no need for any help from anywhere. So the first part of it all is that we have the signature based IDS, and then we have also the anomaly based IDS, where with the signature base we are saying that the system recognizes patterns, recognizes strengths of, traits of malicious attacks, and then with those in their database, the device is able to run through them, and then if there is any occurrence of such malware, it is able to detect and then throws an alarm that the system has been attacked by this particular malware, or let's say the security incident. We also have the anomaly stage, but one of the fall shorts of the signature base is that now it only recognizes signatures that are known. But what about signatures that are not known? Malwares that are not, whose signatures we don't know. What then can we do? So with this, the IDS, which is signature based, would definitely not be able to solve the problem of the day. We will have a lot of malware bypassing this system. So this brought about the introduction of the anomaly-based IDS, which also does the work of actually profiling the behavior of a particular user or the system. And if there's any deviation from this, then it actually throws also an alarm for an attention to be made to the system. But we all know that it also comes with its own challenges, and some of the challenges are that we always experience false alarms, especially when there's a change in policy. The system is not so intelligent enough to tell. But again, we also have some other, models of this IDS, which has a combination of both the anomaly base and a signature base, and that also does the work, but it's not able to harvest the data very well. So what happens here is that we will actually need IT professionals, cybersecurity professionals, to be able to make good use of the data that is being produced on daily basis, and not just responding to alarms, but should be able to check if who actually attacked, which area of our system is vulnerable, at what point in time was the attack done, and what we can predict the next move of the attack. And these are tasks, or these are things that the IDS plus the security professionals may not easily, those of them that do not have access to data wrangling or have some foreknowledge about data science or issues relating to wrangling of data, will be able to do, because they only respond to alert. So here we are saying that the influx of data that is being accumulated by the systems that we develop, plus the fall shorts or the gaps that the IDS or the strategies, the defense strategies that are being implemented now, these two coupled together will need some extensive way of handling the data and handling the system in order to propose a good system that will actually at least give us some surety or protection of our system. We all know very well that security is not 100% correct, all right, or it's not 100%. So we'll at least be assured that we'll be able to detect all the tracks of the offender or the attacker. All right. So please, can we go on to the next phase? So the question is that why do we actually, need cybersecurity data science, or why do we need, data science to be included or to play some role in cybersecurity? So we've started discussing it already that, there are a lot of data actually churning out from the devices that we use in our offices, and these devices are actually windows allowing, or that can allow attackers to get to us. So for any incoming traffic, these systems record them, and as they record them, data is being developed or is being created every now and then. So that's how come we have big data. We say big data is growing and changing at an increasing rapid pace, and therefore there is an urgent need for us to be able to glean insights from it, to act on it, and more timely and more efficiently we should be able to tell what is actually happening, what the devices are recording, in order to make well-informed policies. So we are saying that another reason why cybersecurity is important is that, with this machine learning and data science that we are very enthusiastic about, now, the hackers are also using it. They are implementing it in order to, throw out sophisticated, attacks. And if they are implementing and knowing how powerful artificial intelligence is, it means that they will be a little ahead of us, which can, create a lot of havoc to our systems. And for that reason, we as cybersecurity experts and data scientists will also have to work hard to ensure that we counter some of their implementation. Other than that, they will overcome all our systems, and that will be very dangerous for us. A lot of money would have been lost. So one surprising aspect of it, for which I think cybersecurity data science is important, is that cyber crimes and products are on sale. Now, expect hackers are producing this and selling them out. So here, any person or anybody can go into the market and buy. Where like we have the kiddie scripters who can even go and implement this, and that can cause havoc to our system. So there is an urgent need for us to understand the data that our devices collect and how they should protect our system. We are also saying that yes, attacks are increasing, which we know. And again, since we are using the IDS and just the normal, defense strategies, which sometimes are not properly layered, and if they are not properly layered, it comes with a lot of challenges. So you see that we always have the the 0-day attacks, where the unknown attacks come our way, and our IDS are not able to keep up with what is actually happening, and that can cause us a lot. As I said earlier, we are saying that we have in our offices, we have a lot of devices in a quest to always digitalize our system, to make business processes very effective and efficient, to create value for money. So, and in the quest to be more digitalized, we say we have these devices also recording a lot of logs, and these logs here are to actually help us. And we are not really having the skill now, or we are not really advancing ourselves in order to be able to pay attention to the logs. So the question I ask is that how many of us here bother to even check the Windows event log to find out what is happening? Has anybody done that before? To check what traffic is going in, what the system is doing, whether somebody has compromised with our files. We hardly check that. Yes, but we'll just buy antivirus, hoping that antivirus will help us protect our system. But there is more to it. There's more that we can do. Yes, and the logs are piling up, and manually we will not be able to overcome or make some good insight into these logs if we don't have the data science skills. All right. So going forward, I've said it over and over again. So I said the mode of defense strategy adopted is becoming a little obsolete. Yes, in the sense that they are not properly layered to help us, take advantage of the the zero-day attacks, which is very, very dangerous to our systems. All right, so it is important that we pay so much attention to it and come out with something which you, at least with a blend of cybersecurity and data science, we should be able to make some meaning out of the very data that is collected on daily basis, to protect our system, because data scientists are creating values every day, creating values. But the question is, how do we protect these values? And it's only cybersecurity plus the data science, or entering or going to that ecosystem, helping or administering some of the machine learning processes to ensure that we are protected, from these cyber attacks that have befallen our system. So I want us to go straight away to what data science actually is. I just want us to bruise over it. So you can go to the next page, please. All right. So we are saying that data science is actually a research working area which is existing at an intersection of cybersecurity and data science. So as the name sounds, these are two fields that are actually merging. I see the cybersecurity as the man, and then the data science as the woman. So their conjugation is very important to help cybersecurity protect itself, to empower cybersecurity. So with the emergence of data science in cybersecurity, it's mainly data focus. We all know cybersecurity is about data focus, and also it is also application of machine learning methods, because data science in itself, it's a combination of several fields, and we'll come to get that in the next slide. So with the emergence of cybersecurity data science, then it will help us to be able to, attempt to quantify cybersecurity risks, your incident. At least it helps us to analyze, to understand what is happening in our logs, understand what is happening in our system, and be proactive. So data science is helping to make us proactive, but actually helping to design data-driven intelligent solutions for security. All right. So data science actually is an invaluable weapon against intrusion and attacks. And we have to, as AI enthusiasts, we also have to pay some attention. Let us try to move in that direction also, and then expand the cybersecurity arena with a lot of protection using data science. All right, please can we go on? All right, so somebody will ask, then what is the benefit? I think since from the time I started, elaborating on some of the issues, we'll say that data science really has come to benefit cybersecurity, because it is actually offering a scientific to identifying, attacks on the digital infrastructures, which we have mentioned. So that's one of the, it gives a streamlined process framework through which we can actually have insight into our data, try to find patterns of malware attacks, other incidents which ordinarily our devices or the defense strategies cannot help. So we are saying that it uses data focused approach. That means that our main ingredient here is what? Data. And then by applying machine learning techniques, we are able to identify threats, which is very, very important for us. Yes, one of the good things that data science does is that, for anomaly detection, it's able to, help us, one of the major thing in cybersecurity is what? Finding out the anomalies that happens in our system and reacting to those anomalies. So if data science has come to help detect this anomaly, then it's a plus, because one of the subfields of data science and the machine learning, it's what? Anomaly detection, and that can be applied in cybersecurity, which is very good. So another way is to use machine learning to do penetration testing. For some of us, this is one of the best areas we want to be, because penetration testing it's an offensive way of actually protecting the system. And if we can use, machine learning to do penetration testing, then we'll be able to be proactive, in saving or protecting our information systems. All right. So a lot of benefits. So we can go down to. So this is a typical cybersecurity, or an infrastructure, an office infrastructure or an edifice which is housing information system. So as we can see, you can see your IDS, you can see your ICM, you can see the workstation, the router, everything. This is a complete, infrastructure, an information system infrastructure. And all these devices that are in this infrastructure are collecting data. But how do, and they are all windows, or they are all windows for the attacker to move in. And any movement that goes into these devices is being monitored, and the log takes care of that. So we have a lot of data sets which is available for cybersecurity. All right, and this can be found in all the devices that you is displayed or is on the presentation. And the consequence of ignoring these security challenges will be detrimental to our, solving the problem of cybersecurity incidents that we have as a nation or as a world. So the use of data science really helps to overcome the gap that is raised in the cybersecurity, strategies, and we would have to work so hard to see how best. So what is cybersecurity data sets? What is cybersecurity data set? We are saying that they are the raw security data collected from relevant cybersecurity sources and used to analyze the various patterns of security incidents or malicious behavior in order to build a data-driven security model. So these are all the data. So all these, the logs that you see around, I can see a lot of them. They are all cybersecurity data. And how would you and I be able, as AI enthusiasts, be able to aggregate all these data together, wrangle them, put them into a model to help us to either predict, detect, or do any other thing in order to safeguard our information system? So these data sets are very important for us as data science enthusiasts, AI enthusiasts. We need data, and a lot of them are there. So when you go into your institutions, you can start finding out where all these logs are and what you can do with them as an enthusiast of data science. So can we move on, please? All right. So you can see a very nice data set, but ordinarily you don't get the data sets like this in the device that I showed you, because they are not in this phone. This is a refined one, where the data set tells us about the attacks, the sub attacks, the protocol being implemented, the source IP, the source ports, the destination IP, the attack name, the attack reference, and the most important thing is that the time the attack took place. All right, so with this smart data set, it doesn't just come easy. You have to do a lot of, data preparation in order to reach this level of data set. And this data set can give us a lot of benefit. Yes, for example, it can help us to know the most targeted, destination IP. Okay, in our infrastructure, it can help us to know the most logical port that has been attacked or that will be attacked. Most frequently, the frequent attacks that really are being met on the organization or the infrastructure. This data can really help you to do that. And then it can even help you with the help of the time. You'll be able to tell even at which time of the day do we have these attacks being done. I'm sure you'll be, a prophet to be able to tell that, okay, this attack can happen at this time. And it's only data being harnessed will help us, and data science has that power, or that the features, or let's say the techniques to help us to be able to answer some of these questions, and even to find a pattern of the attack and when the next attack could be done. Data sets of this nature can really help us. But how do we get this data set? Looking at all the device and the logs that we have. So we can proceed now. All right. So it is very difficult to get cybersecurity data, though we have them around us, but we don't have the knowledge to harvest them. But to train a model, you need a good data set to work with. And luckily for us, we have some institutions who have prepared some data sets from which we can get cybersecurity data sets, and that we can use to do a lot of the analysis that we can do, or we can help prepare the model before we implement them in our infrastructure. So, but one thing about some of these data sets is that they are some of them are old. You can see the years. Some of them 1998, 2000, and by then, internet in itself has not gotten to a point like we have today. So clearly, you can say that some of these data sets are obsolete. However, they still carry some value if well looked at. Okay, so we have, but the one that interests me so much, which I think that most of us who are interested in cybersecurity data science can look at, is this site, the one, the how do you call it, the secrepo.com. The secrepo.com has a lot of data sets, somehow up to date, which we can use with the skill that we have in data science to be able to find out what analysis we can do in order to, first of all, detect malware, detect some incidences or deviation from the normal behavior of the systems that we use. So at the end of the whole lecture, I think the slide we made available, and then we can go to harvest some of these data sets that will really help us to make have some insight, or develop some patterns, or identify some patterns in these data set for us to get it implemented in our organization. So please, you can go on now. All right, so I think you've missed one of the slides. I think you have missed one of the slides, right? Okay, that's okay. You can move on. All right, so yes, so just to review, go back to our data science a little. So we started talking about data science having a lot of fields, all right? So as you can see, your data science really encompasses a lot of areas. You need to have mathematics and statistics skills. So for some of us who are so much afraid of statistics, though it has been made much simpler for us by the models, the libraries that we have, which already have prepared, techniques in statistics. But we need to have a fundamental understanding about all these fields, the computer science. But you don't really have to be a computer science student in order to delve into data science anyway. But you have to get the basis, because you need to work on data. You need to use SQL. You need to understand the infrastructure that you are getting the information for. So it's very important. The most important aspect also is the business or the domain expertise. So right now, the domain expertise that we are working in now is the cybersecurity. All right, so we could have other fields. So like I said before, we have had many of us working in other fields, other domain, banking sector, health sector, and other sectors. And now we have the cybersecurity sector, because we need to have our data that we have created value from protected. All right, so how do we get it done? For some of us, what is the process? What's the process involved in data science? Also the anomaly, which is what we are looking for to detect. And again, we have another one, which is the noise. in every data set, there are noise in the data set. And that is why in the exploration stage, in the preparation of the data, you have to take away this noise so that you can have only the real data and have also the anomaly. Then you can be able to detect the anomaly. So, under supervised learning, we have the anomaly detection, which really helps us to get it implemented, have an implementation in cybersecurity. All right, so we can move on, please. All right, so just to have a little for some of us who want to see how it is, the overview, at least pictures really helps than talking. So you can see some of the techniques under classification. We have the nav-based classifier, and you see how the pictures look like. It tells you that you have a lot of data points, and through probabilistic processes, this data is being classified into various forms, and it is very useful in cybersecurity, and we are going to see how it is, some of the areas or some of the tasks in cybersecurity that these techniques are used. So we also have the k nearest neighbor, which is also another classification one. And then we have the k-means, we have the support vector machine, we have the logistic regression, decision tree, we also have the random forest, which is a group of decision trees. So these are all techniques that are found in data science, and it's so much implemented in cybersecurity to help with some of the issues, because in malware analysis, we will be able to classify, like I said earlier, whether we have a spyware, ransomware, or other type of malicious software. We also have the fraud detection. So in the fraud detection, we're able to know which type of the fraud is being implemented, or let's say is affecting the organization and or the banks, and then policies can be made in that direction to ensure that that type of fraud is being eliminated or reduced to the barest minimum. Okay, so can we go on, please? All right, so so then we now let's see. So we've mentioned some of the classification techniques, and let's see what it does. So we have the nav-based classifier, and one of the very good things that it does is to help us build an intrusion detection system, which will help us to detect, to make sure that any cybersecurity incident that come or that appear or that showcase itself in the system is being protected. So intrusion, as we know, is a process of monitoring and analyzing the events occurring in the network or in a system in order to detect signs of the security problems. And nav-based classifier is one of the simple and the most effective classification algorithms, which will help make quick predictions. All right, and like I said earlier, it's a probabilistic classifier. All right, so it also helps us to classify intrusions that get into the system, and then help us to know which one is the good one, which one is legitimate, and which one is illegal. All right, so the nav-based classifier does that. It's unfortunate we can't dirty ourselves with some codes because the time is very limited, and perhaps you can also go and then do some research on this. There are a lot of data and documentations on how to build intrusion detection system using the nav-based classifier. Another one is also the k-means, the k nearest neighbor. It can also be used to build a network intrusion detection system, and its main purpose is to reduce the false alarms, because we know that this anomaly detection IDS that is being used actually even responds to even policy changes, which should not be. So with the use of the k nearest neighbor, we should be able to classify if a particular event that took place in the network is legitimate or not, or it is not an attack on the system. So the k nearest neighbor does that work. So we can sink a little deeper into this if you are so much interested in cybersecurity data science, and some of us love it so much. All right, so we can move on. Hello. All right, good. So another technique that we saw at the third slide from here is the support vector machine, and we can also see the logistic regression. These are all techniques, and they can help to classify various attacks that that affect the system. Okay, an example, the denial of service attacks and the other attacks that can affect the system. Now, with the vector, the support vector machine and some implementation of data and machine learning techniques, we are able to do feature selection, which I'm very sure the data science enthusiasts will understand the importance of feature selection, because it helps us prepare the model and make the model very, very effective. All right, so intrusion detection can be done using the same support vector machine support vector machine technique or algorithm. All right, it can be implemented. The same for distributed denial of service detection analysis in any environment of a sort. Okay, then in order for us to evaluate the host based anomaly detection, like our PCs, the personal computers that we use, we can at least help with the logistic regression. We'll be able to assess whether a system is being affected by a malware or not, or whether we are having an intruder in our system. And logistic regression, which is able to say, okay, yeah, this particular attack or this particular URL, it is either a benign URL or it is a legitimate URL. And logistic regression really helps so much in that atmosphere. All right, so let's go on. So in actual fact, it's a huge field, though just emerging is a huge field, and I think some people even take hours and hours to just digest the inputs on this particular subject, but because of our time, we'll just have to look. So decision tree and random forest also has the capability of helping to detect malicious code's behavior. You understand, and information by running malicious code on a virtual machine and analyzing the behavior information for intrusion, because all we want to do is to find out if this particular incident or this event, does it match the policies that we have inputted in our organization? If not, then it is a malicious code, or it's a malicious attack. So decision tree really helps in that direction to be able to profile the behavior of a particular user or the particular entity, a system, and then being able to find out if that action being taken by the user or taken by a particular entity or device is really what is acceptable. If not, then it's able to mitigate any action that is being raised. All right, so can we move on please to the next slide? Yeah. Okay, so we've just talked about the classification, but we also know that regression also has its part to play in cybersecurity defense solutions. All right. Regression is widely used. I think it's the most simplest of all the algorithms that is being used so far, because it's able to tell us numerically what is actually happening, the effect between two relationship between two instances or variables or features. All right, so one of them is to predict, let's say, the total phishing attacks in the particular period. So over the month we can foretell whether we're going to have an increase in attacks or not. And linear regression can really help us to determine some of these, quantify the risk, based on some independent variables that are made available, or that we have in our data sets. All right, so like we said determination of trends in the security events, as well as prediction of the behavior of machines and users. So we want to know that which of the the port is more targeted, which IP address within the infrastructure is more targeted, and the most logical port that has been attacked, and then the different time of the day where attack has happened, and most importantly, like I said before, to be able to find the pattern. How is it going? Is it increasing? Are we seeing an increase on Sundays in the evening? What is actually happening? So linear regression really plays a major role in trying to quantify the cyber attacks or the security incidents that we face, or our infrastructures are bedeviled with. Okay. So we can explore a lot of it. We have a lot of data sets that are available. Then we have the support vector regression, which is also another subsection of support vector machines. It operates like the support vector machines. But like we know, regression actually deals basically with linear regression, deals basically with numerical values. All right, so in implementing support vector machine in a numerical context, we say support vector regression. It's also being used, and we can delve a little bit in that on your own to see how supportive that can be to the fight against cyber attacks. So aside the ones we have talked about, there are a lot of tasks that we can look at. I mentioned some of them. All right. So we said that in order to discover suspicious, HTTP requests, regression can help us to do that, and even comparing requested network packets parameters to their typical values. We can harness or harvest that data and try to do those comparisons to see whether the values are the normal values that should be assigned to the packet parameters that are being connected or that are flowing within our networks. Again, we said finding unexpected system calls, alerts that's really are going to find out if really those alerts are worth working on. And we are also saying that in order to predict total phishing attacks, which you have already mentioned, so regression has those capabilities, predicting the network packet parameters and also comparing them with their values to see whether they are really accurate. So we can delve a lot into that also, but for the sake of time, can we proceed, please? So before we go there, we are saying that endpoint security is a major concern for many offices, especially those with remote workers. So regression, we are saying that can help us really detect if unfamiliar laptops, routers or other endpoint devices trying to connect to our network. And that is in the purview or the capability of regression, which linear regression plays a critical role. Another sub area of machine learning is the clustering, which is also an unsupervised learning, which we already talked about, where the model must teach itself. So this time around, the model must teach itself to identify the relationship between the data points or between the data that you have collected, and to find out how similar they look like. So for example, if you realize that in a particular network system, you have a clustering of group of users, and then you have only one outlier, that will at least trigger an alarm for you to know that, okay, where is that single person coming from? Because that person's activity on the network looks quite different from the rest. So clustering helps you to do those identification, helps you to identify some of these anomaly that you have in the system. All right, and k-means is used, the k-median, the k-midpoints. These are all clustering techniques that can help in the fight against these attacks, making sure that we are ahead of the attacker. So k-means can be used to build intrusion detection system. Actually, it's also very helpful in that regard. So can we go on, please? And can we go on, please? So the main goal of clustering actually, like I said before, is to help us sort the data into various groups based on which data points most resemble one another, that they look alike, like we can see in the picture, very, very clear. So you see that in the first point, we have a lot of data points, actions of users. We can just say, okay, malware, or let's say legit activities of users. And then based on activity, we are able to provide some model, feed them into a model, train, and we'll be able to detect that no, there are almost three separate activities that are going on. Why these three activities? We need to understand why. And the why will help us by building an intrusion detection system using the k-means, which will be able to at least classify them, and then we can investigate to understand which is not legitimate and which is a burning, activity, or an activity that is not really harmful to our system. Right? So the k-means plus the k nearest neighbor in combination can help us do a lot of work in cybersecurity. Yes. Yeah, I know you know of ensemble learning, where you can back together a lot of techniques or algorithms to train a model, and then you are able to detect which of the models, which of the techniques or algorithm works best, and then that can help you be sure that the outcome that you want for your system is up and doing. Yeah, so clustering is also doing its bit in the cybersecurity space to build intrusion detection system. Please, you can move on. All right. So the question is, what are some of the tasks? Because if you don't know the problem, you cannot know what to do. You can have the data set, but if you don't know the question to ask the data set, then it becomes somehow useless. Okay, so we should be able to identify problems in the cybersecurity ecosystem or space and try to seek, help from the data to answer those questions, like we have in the life cycle that I showed you earlier on. So some of the techniques of the use cases in cybersecurity are like analyzing forensic, trying to have a close look at the system in entirety to find out if there's an intruder. For example, if somebody should impersonate an admin's credential, all right, we should be able to come up with the model, the clustering, like I described earlier. So you see that person will have a separate, the IP address location will be very distant, or let's say will not be, resemble the location of the other IP addresses. And that can tell you if there's an intruder, or there's a user who is geographically displaced but is accessing the system or your infrastructure. And that can be explained, especially if you have information that, okay, somebody, an IT officer living in another jurisdiction, is giving the permission to access the infrastructure, and that will explain it. Other than that, they will conclude that there is an attacker somewhere, and clustering is so good at that. And it's able to detect unauthorized user logging in at a straight time or from a different location than the usual. Very, very critical. So another one is protecting email account from malware. So that's where the spam filtering comes in. I know most of you probably will be very versed in that, and I wouldn't have to go so deep into that now. I'll just leave it. So spam is being recognized in our email systems here and there. So we're able to tell whether this email is a spam or it's not a spam, and clustering can also do that. All right, and then to be able to uncover the hidden patterns and structures from data sets. Yes, so that we've also talked about. Okay, so data set has a lot of value in it to help us protect our infrastructure. Wonderful data, security data sets. It can really help us go a long way. And data scientists must begin to get into cybersecurity ecosystem to help harvest this data, make meaning out of it, build frameworks that will entirely leave no loophole in our infrastructure. Please, can we go on? Are we there? All right. So there are a lot of other tasks. I'm sure as we go along, people will be discovering a lot of tasks by studying the data and looking at the data, exploring the data. Sometimes you find out a lot of questions, and I think one of them, you can use some of these how do you call it, machine learning techniques, which they are readily available. It's about understanding them and knowing when to implement them, and then you are good to go. You should understand your question. You should be able to harvest the data, process it, make it more viable for the model to train effectively on it in order to have a good performance of predicting what you want to predict. All right. So we have deep learning convolutional, which I didn't delve into. I didn't mention that, but that also really helps. The neural networks, they also play a major role in helping to fight against cybersecurity threats in our infrastructures. Yeah. Then the most exciting part, which I love so much, reinforcement learning. All right, so reinforcement learning is also one very good subsection of the ML or the machine learning, where we have an agent who learns his environment, like we have the self-driving car. So if you have a system in place where the algorithm can really learn by itself, learn what attack comes, and then react to the attack. So if the attacker should move one step, the reinforcement model can also, sense the step and be able to react in that order. So reinforcement has a lot of prospects, and I think that a lot of cybersecurity that are implementing machine learning are making use of reinforcement technique, which is actually helping to fight the threats by learning its environment, by ensuring that acting on the information that it gets from its environment in order to fight the cyber insecurity incident that we have. Okay, so please, you can move on to probably the last slide or so. Okay, so again, we will say that cybersecurity in itself is a huge fraternity, and yes, that's the last one. The huge fraternity, and then it has gotten married to another area of research, which also is very huge, and the two of them coming together are not without challenges. There are really challenges in this field of data science, and it is not that rosy as the way we are so enthusiastic about it. Data science, cybersecurity data science, and the power of machine learning and its implementation in cybersecurity is something so wonderful to think about, and we have to research into it. But it comes with its own challenges. Like we said previously, we said yes, there are data that can really help us to train our model, but some of these data are obsolete, they are old, and they are not even up to date because, like we said before in the first slide, that 90% of the data that has been produced was done actually in 2 years ago, and the increase in digitalization is increasing at a exponential rate. So as they increase, the malware infestations and development of malware and intrusion, attacks are also being sophisticatedly done. So if we're still using the old data to train the models, then we are not going to get the best fight or counter. We are not going to play that counter, lifestyle towards these hackers who are, using AI to do so many great things, so marvelous things, which we have to be up to date to ensure that we are ethically fighting against them to prevent our system. So we are also saying that, there are a lot of data. Earlier we talked about it. Almost every device, the IoT devices we have around in our offices, our our computers, our phones. Some organizations have BYOD, which is the bring your device to the organization, which is being used for some of the business processes. Now, they are all creating a lot of data, and as a normal cybersecurity professional, it is very difficult to make good use of this data, or to be able to harvest them, aggregate them into smart data sets that can help get insight into the data set to find out what is actually happening, what is going to happen. These are very critical things. So this data, we are overwhelmed. They are really overwhelmed. Cybersecurity, the SOC, which is the Security Operations Center, actually is overwhelmed with volumes of data. All right. Some ignore them because if you don't know the use, why attempt it? All right. So there's so much, ignoring of this volume of data, and they are termed as dark. They become dark data because they are not used, because it is becoming increasingly high. And how do we fight against it, or how do we work in order to ensure that this data produce great value? Because one of the importance of data is that it creates value, because it is a gold mine for the world this day. That's why Google, Netflix, and other high profile organizations are really making a lot of good dollars from this data, because they know the importance of it. And organizations can do same in the vein of making money and also protecting their system. Another point that I think I clearly discussed is the lack of prepared data and context. So you cannot be able to work on this data if you don't have the know-how on how to harvest the data, process the data, and be able to create some insight. You can only do that by using data science. That is why it is important that we invite data science into our cybersecurity policies. We have to employ data scientists who should be trained on cybersecurity, who should be able to identify the data sets we have, identify the problems, and help to reduce the cybersecurity incidents that we are facing. Then last but not the least, we are saying that lack of protection of valuable security information. I'm very sure that most organizations, especially in Ghana, probably don't know that they are even collecting some amount of data, on cybersecurity. And as to whether the data we have, are we really even protecting it? Are we encrypting it to ensure that the data is not lost? Because anytime an attacker invades your infrastructure, one of the things it does is to make sure that it deletes, or it covers up it tracks, so that you're not able to detect it. And the worst of it is to destroy your data, so that all the valuable data that you have, you cannot have it again. And one of the challenges that we are facing is that most organizations are also not paying so much attention to protecting their data. And for that matter, it is very difficult for to get available data sets, or to aggregate data sets from all these devices to help develop some framework, develop some models that will be data driven, to solve problems, cybersecurity problems in the organizations. And for me, one of the areas that I'm so bent in working, and I've started working in, is to provide these services to small and medium scale organizations, because they are getting excited about utilization. But at the end of it all, they don't understand the loopholes that they are facing. By buying antivirus IDS, yes, they are fine, and they end up having been infected, and a lot of money being lost from this infestation, and then also other insider threats which have not been detected, and they end up at the court and so many problems. But the sure way is to make use of the data that we are depositing every day at a high speed, though it has unformatted way. But with the presence of data science, we should be able to make some meaning and make some headway, all right, in the quest to fight against cybersecurity threats. Yes, just the last one before I seek for questions and also pull down my gun is to say that people are also making strides. The fact that we are talking all about this, people are taking the lead. There are a lot of organizations that are working so hard to bring products that are that are machine learning based, that are machine learning based. And I discovered the deep fault application. And what it does is that it really helps. So it's rather deep exploits. Deep exploit is an advanced, intrusion detection application that has inculcated in it machine learning, and is for pen testing processes. So here it is able to do intelligence gathering, threat modeling, vulnerability analysis, exploitation, post-exploitation, and reporting. Wonderful. So uh, machine learning can be bundled into products that can fit into the cybersecurity infrastructure, and I think people are taking the lead. And for us in the other part of the world, it's important that we look at it from our point. We're not so much interested in buying already prepared products, because those already prepared products might not discover a lot than we will have to go deep into the data as scientists. That's why I encourage all organizations to, as you fight, you employ cybersecurity as an approach to, uh, preventing attacks. We have to ensure that we're part of the team to ensure that this data patterns are realized in order to, and it's also one of the tools recently which has machine learning forming part, or let's say artificial intelligence really been inculcated in it. Another one is the Sophos Intercept X2. It also has that, so you can go and read about some of the various tools that are using various algorithms of AI to get best security to organizations. So thank you very much, ladies and gentlemen. I think I have spoken at length on the issue of cybersecurity data science, though it's very vast and huge, but I'm pretty sure I've been able to at least touch on some very important points that will at least make you more enthusiastic to learn into this field, because it is an exciting field. To ladies and gentlemen, for giving me to digest some of the overview of data science cybersecurity data science. Thank you very much.